Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a 3D isometric projection of an engineering object into which the front face, the right hand side view face and the top view face of the object, they have been combined into a single 3D isometric projection over here. So now using the information available with us into this 3D isometric projection, we are required to obtain the front view orthographic projections, the right hand side view orthographic projections and the top view orthographic projections corresponding to this engineering object over here. So now in order to obtain the orthographic projections of the solid, we need to obtain the dimensions of the front view face, the top view face and the right hand side view face over here. So as we look at the solid from the front view into this direction, we obtain that the width of the solid happens to be 120 millimeter, while we have not been provided with the total height of the object directly over here. So we need to evaluate the height of the object by looking at the geometry of this particular object and combining the heights corresponding to different elements of this particular object. So as we look at this object from this particular orientation, so we obtain that the height corresponding to the left hand side face of the object, it happens to be equal to 35 millimeter. And because we have got a vertical web onto the left hand side portion of the solid, so the height of this vertical web which is lying on the left hand side portion of the solid, it happens to be 10 millimeter. So now we obtain that the height of this horizontal surface, it happens to be 35 millimeter minus 10 millimeter, that is 25 millimeter over here. Now we know that on the right hand portion of the solid, we have got two square blocks over here. So this is square block number 1. This is square block number 2. So the dimensions of the square block, they happen to be 15 millimeter by 15 millimeter square cross section, and the height of the square block, it happens to be equal to 20 millimeter. So now we obtain that this portion which is available towards the right hand side of this particular solid, this is at a height of 45 millimeter from the ground. So now we obtain that the front view face of this object, it is going to have the dimensions 120 millimeter width of the solid and 45 millimeter will be the height of the solid. When we look at the solid from the top, so now we obtain that the width of the solid happens to be 120 millimeter, while the depth of the solid happens to be equal to 60 millimeter over here. So the top view face is going to measure 120 millimeter width by 60 millimeter depth of the solid over here. While we look at the solid from the right hand side, so again we observe that the depth of the solid happens to be equal to 60 millimeter, while the height of the solid happens to be equal to 45 millimeter. So the side view face will be having the dimension 60 millimeter depth of the solid and 45 millimeter, it is the height of the solid. So this way we have evaluated the dimensions of the front view face, top view face and the side view face over here. So with this information, we are required to obtain the orthographic projections of the solid over here. So now we have drawn the XY reference line, X1, Y1 reference line and a transfer line inclined at an angle of 45 degree, so that we can transfer all the linear distances alongside the depth of the solid from the top view projections into the right hand side view projections over here. So since we are going to obtain the orthographic projections into the first angle projection method, so the front view projections will be obtained above the XY reference line. The top view projections will be obtained below the XY reference line, and the right hand side view projections will be obtained on the left hand side corresponding to the front view projections for this particular object over here. So now we know that into the front view face, the dimensions will be 120 millimeter. It happens to be the width of the solid, and 45 millimeter happens to be the height of the solid. We have drawn two vertical projector lines which are available with us at a distance of 120 millimeter, which is equal to the width of the solid. And these two vertical projector lines, they have been obtained into the front view projections, and they have been extended appropriately into the top view projection area, because into the top view projections also the width of the solid will be equal to 120 millimeter. We know that the height of the solid happens to be 45 millimeter. So now we have drawn one horizontal projector line into the front view projections and extended this projection line into the right hand side view projection area over here, because into the right hand side view also the height of the solid, it will be equal to 45 millimeter. So this horizontal projector line we have drawn at a height of 45 millimeter above the XY reference line. So this way the projections corresponding to the front view face measuring 120 millimeter width and 45 millimeter height, they have been obtained over here. Now we know that the depth of the solid happens to be 60 millimeter. So into the top view projections, we have already obtained width of the solid, it is equal to 120 millimeter. Now two horizontal lines we have drawn into the top view projections, which are separated by the distance equal to 60 millimeter, which happens to be the depth of the solid over here. And these horizontal projector lines we have transferred into the right hand side view projection view using this transfer line over here. So now we can check that this distance between these two vertical projector lines, this will also be equal to depth of the solid into the right hand side view projections over here, and this distance will be equal to 60 millimeter. We have been able to obtain the right hand side view face having dimensions 60 millimeter, it is the depth of the solid, and 45 millimeter, it is the height of the solid. So this way the orthographic projections corresponding to the front view face, top view face and the side view face, they have been appropriately marked into the orthographic projections view over here. So now let us divide this object into multiple elements over here. So element number 1, it happens to be a horizontal wave which is having thickness or the height equal to 25 millimeter on the left hand side, and the height or thickness on the right hand side happens to be equal to 15 millimeter. And into this horizontal wave there is a rectangular slot which has been provided, which is having dimensions 10 millimeter. Height of this slot is there, and 60 millimeter, it is the width of this rectangular slot which has been provided onto the right hand side portion of this horizontal block over here. Then the element number 2, it happens to be a vertical wave which is having height equal to 10 millimeter and it is having depth is equal to 60 millimeter. Then we have got element number 3. So these are two square blocks which are located on the right hand side of the solid, and these two square blocks, they are available in a symmetrical position in such a way, one of the blocks it is available on the front side and the second square block is available on the rear side of the solid over here. And the dimensions of the square block, they happen to be 15 by 15 square from the top, having a height of 20 millimeter over there above the top surface of this horizontal web which is lying onto the base of the solid. So now we know that the dimension of the square block, that is element number 3, it happens to be 15 millimeter by 15 millimeter. So we have marked a distance of 15 millimeter corresponding to these two square blocks which will be overlapping with each other into the front view projections over here. So this width of the square block we have marked as 15 millimeter, and we have drawn a vertical projector line into the front view projections at a distance of 15 millimeter from the right hand side face of the solid, and we have extended this vertical projector line into the top view projections as well. Similarly, we know that there is a vertical web which is lying onto the left hand side portion of the solid, and it is having the dimensions width is equal to 15 millimeter, height it is equal to 10 millimeter. Now corresponding to this vertical web width over here, which again happens to be 15 millimeter, so we have marked a distance of 15 millimeter from the left face of this particular solid corresponding to this element number 2, which is a vertical wave which is resting on top of the horizontal block which is resting onto the base. So now we have drawn a vertical projector line at a distance of 15 millimeter from the left hand side face into the front view projections, and this vertical projector we have extended into the top view projections as well. Now next we know that corresponding to the square, we know that the depth of the two elements, that is element number 3. So corresponding to these two square vertical blocks, so the depth happens to be 15 millimeter. So one square block we have discussed, it is lying on the rear side of the solid onto the right hand side portion of the solid, whereas the other square block is lying onto the front side of the solid on the right hand side portion of the solid. So corresponding to the depth of this particular square block over here which is resting onto the rear side, so we have marked a distance of 15 millimeter from the rear face of the solid. So this is the rear face of the solid. So we have marked this distance as 15 millimeter, and we have drawn a horizontal projector line at a distance of 15 millimeter from the rear face into the top view projections, and we have transferred this line appropriately into the right hand side view projections using this transfer line over here. Similarly, corresponding to the front side block, so the depth happens to be 15 millimeter. So from the front face of the solid, so this is the front face of the solid, we have marked a projector line at a distance of 15 millimeter from the front face into the top view projections, and this horizontal projector line once again we have transferred it into the right hand side view projections using this transfer line over here. Now another thing we know that into this horizontal block we have been provided with two circular holes having diameter 20 millimeter, but there is a difference between these two holes. Even though their diameters happen to be the same, that is 20 millimeter, but the height of this hole, it happens to be 25 millimeter because it is lying on the left hand side portion of the solid. Now this circular hole is having height, it is equal to 15 millimeter because into this right side portion we have got a rectangular slot provided over here at the base of the solid. So now we know that there are two circular holes which have been provided over here. What is the location corresponding to these two holes? We know that these two holes, they are available at the center of the solid as we are going to look at this solid from the right hand side view. So total depth of the solid is 60 millimeter. So we are going to measure distance of 30 millimeter from the rear face. So this center line will be located in the top view projection, and this center line has once again, it has been transferred into the right hand side view projections using this transfer line over here. So the center line corresponding to the two holes into the top view, it has been located over here. So now let us locate the center of these holes into the front view projections as well. So now we know that from the left hand side face, this web width will be equal to 15 millimeter. Now from this vertical face of the web which is existing over here, if we move 20 millimeter towards the right hand side, then we will find that the center of the first hole will be located over here. So as we move towards right from this vertical face of the element number 2, that is the vertical web over here. So at a distance of 20 millimeter, we can mark a vertical center line or a projector line over here, which is going to depict the location of the circular hole center point over here. So now we have identified the location of center point. We can check it out over here. This is the center point of hole number 1 corresponding to this hole, which is having diameter is equal to 20 millimeter. Now how do we locate the location of the center point corresponding to the hole number 2? So we know that center to center distance corresponding to these two holes on the top surface of this horizontal web, it happens to be 45 millimeter. So center to center distance between the two holes we know as 45 millimeter. So now at a distance of 45 millimeter towards right hand side from the center location of the hole number 1, so the center of the hole number 2 has been located. So again, a center line corresponding to hole number 2 has been obtained into the front view projections, and it has been appropriately extended into the top view projections as well. So the center point for hole number 2 has been located. Center point for hole number 1 has also been located over here into the top view projection and into the front view projections as well. So now we can check that since the diameter of the hole number 1 and hole number 2, it is identical, that is 20 millimeter. So from these center lines which we had obtained into the front view projections and into the top view projection, now we are going to have an offset of 10 millimeter on either side of the center line, so that the diameter of this hole number 1, it is equal to 20 millimeter, can be obtained into the front view projections, and the diameter of the hole as 20 millimeter, it has been obtained into the top view projections as well. Similarly, corresponding to hole number 2, so this was our center line. So from the center line, we have taken offset of 10 millimeter on either side of the center line. So two projector lines we have drawn into the front view projections and extended them into the top view projections, such that the distance between these two projector lines, it will be equal to 20 millimeter, which is going to depict the diameter of the hole is equal to 20 millimeter over here. Now another thing we know that on the left hand side, so this we have already discussed, the height of the solid, it is equal to 35 millimeter, that is horizontal web, it is having height is equal to 25 millimeter. Vertical web, which is lying on the left hand side portion of the solid, it is having height is equal to 10 millimeter. So the total height of the solid on the left hand side, it is equal to 35 millimeter. So at a height of 35 millimeter from the ground, we have marked one horizontal projector line into the front view projections, and it has been extended into the top view projections as well. Another thing we know that at a height of 25 millimeter, we have got the top surface of this horizontal web, which happens to be our element number 1 over here. So corresponding to horizontal web or element number 1, so we have marked this distance of 10 millimeter from the top face over here. So if we move down by 10 millimeter, so the top face height 25 millimeter will be obtained over here. So now we have obtained the height of the top face of the horizontal web as 25 millimeter into the front view projections over here, and this horizontal projector line has once again been extended into the right hand side view projections over here. Another thing we know that into this horizontal web, we have got a rectangular slot which is having height is equal to 10 millimeter, width is equal to 60 millimeter, and depth is equal to 60 millimeter, which has been cut at the base of the solid onto the right hand side portion of the solid. So corresponding to this rectangular slot, 10 millimeter height we have marked into the front view projections, and another horizontal projector line has been evaluated into the front view projections, and this has been appropriately extended into the right hand side view projections as well. And also we know that the width of this particular slot, it happens to be equal to 60 millimeter. So now from the right hand side face, we are going to mark a distance of 60 millimeter as we move 60 millimeter towards the left side. So wherever we mark this distance 60 millimeter, one vertical projector line we have obtained into the front view projections, and this projector line has been appropriately extended into the top view projection. Now by drawing this vertical projector line, now we can see this is the rectangular slot which will be visible to the observer, as the observer is going to look at the solid from the front view side. We can check. So this position and this position, it is going to describe the rectangular slot which will be visible to the observer. So now we can check as we move along from the right hand face 10 millimeter above the base of the solid. Now this is the rectangular slot which has been cut onto the right hand side portion of this horizontal web. This height will be equal to 15 millimeter, and this height on the right hand side corresponding to these two square blocks, it happens to be equal to 20 millimeter, and this width corresponding to these two vertical square blocks, it happens to be 15 millimeter. So now we can check onto the left hand side portion. We have got the height of this horizontal block equal to 25 millimeter, whereas the element number 2, which is the vertical web which is lying on top of the horizontal surface of this particular element number 1 onto the left hand side portion of the solid, this is equal to 10 millimeter. So onto the left hand side we observe that the height of the solid is 35 millimeter, whereas onto the right hand side the height of the solid happens to be equal to 45 millimeter. So now we can check. We have already marked the location of the holes over here. So the right hand side hole, or the hole number 2, we had marked over here. This was the center line. Diameter of 20 millimeter has been marked over here. But one thing we must observe, this hole number 2 or hole number 1, both of these holes, they will not be visible to the observer from the front view projections over here. So they will be appearing as hidden line projections into the front view projections over here. So now we can check through this construction that the height of hole number 2, it happens to be equal to 15 millimeter, whereas the height of hole number 1 over here, which is again having diameter is equal to 20 millimeter. So this height of the hole happens to be equal to 25 millimeter. And one more thing we need to observe, that this horizontal portion of the element number 1, so this portion is also not visible to the observer from the front side, because one of the vertical square block, it is going to obstruct the view of this portion of the horizontal element over here. So this portion will be visible to us as a dotted line over here. So this dotted line we have obtained corresponding to this hidden portion, which is getting hidden by this vertical square block which is lying onto the front side of the solid. Now as the observer is going to look at the solid from the top, so the boundary of the solid, it will be visible to the observer from the top view projections over here, because at all points of time, even though the cross section heights they may be different, but there is continuity in the surface which is maintained on either side of this particular cross section which is visible to the observer from the top view projections over here. Another thing we can observe, corresponding to this element number 2, we have already evaluated the width of this vertical web, it happens to be equal to 15 millimeter. So this width we have already marked into the front view projections. So onto this projector line, if we mark an object line projection over here having depth is equal to 60 millimeter, so this vertical web top view true shape projections we are able to evaluate into the top view projections over here. Another thing we can observe over here, because of this rectangular slot which has been provided onto the base of the horizontal web on the right hand side, so this cross section, this rectangular face which is lying below this particular horizontal face over here, so now this will not be visible to the observer. So this will be obtained as a hidden line into the top view projections over here. So corresponding to this rectangular face, we are going to obtain a hidden line projection which will be appearing as edge view projections corresponding to this vertical face of the rectangular slot which is available at the bottom of the horizontal web over here. Another thing we can check, corresponding to these two vertical square blocks having dimensions 15 millimeter by 15 millimeter. So now we can join two blocks over here, one block at the rear having square 15 by 15. So here we can check depth is 15 and the width is 15, corresponding to another square block which happens to lie on the front side of the solid. So here we have got the depth is equal to 15 and the width is equal to 15 over here. Now we are left with these two holes over here having diameter of 20 millimeter each. So the center point of hole number 1, center point of hole number 2 has already been evaluated. So using these two center points, now we have been able to obtain the circular hole having diameter is equal to 20 millimeter on the left hand side, another circular hole having diameter equal to 20 millimeter on the right hand side through the center point has been obtained over here. And now we can check if we are going to look at the solid from the right hand side view over here. So we observe that once again we are going to observe this cross section, that is base will be visible through this particular slot. We can check the base will be visible, the full height of 45 millimeter will be visible, and this rectangular slot which is having the dimensions, we can check this is 15, this is 15. So the depth 30 millimeter will be left in between and the height will be 20 millimeter in between. So depth will be, we can check, this dimension happens to be 30 millimeter and this height happens to be equal to 20 millimeter. We can check it out over here. This height of the vertical block, it happens to be equal to 20 millimeter. So height of this vertical block happens to be 20 millimeter. Then this horizontal face, it is having depth is equal to 30 millimeter. So this portion of the solid will be visible to us. Now we can check over here that into this rectangular slot, we will be able to visualize this particular web over here. And one thing we must remember, the height of the left side web happens to be 35 millimeter, while the height of the right side web happens to be 45 millimeter. So this total web, it will not be visible to the observer from the right hand side. So only the middle 30 millimeter portion of this web which is available at a height of 35 millimeter, this will be visible to the observer as an object line, while the remaining 15 millimeter on the front side and 15 millimeter on the rear side of the solid. So this portion of the web, it will be visible to the observer as a dotted line over here. So we can check this web which is available at a height of 35 millimeter. We can check this height of the element number 2 top surface. This happens to be 35 millimeter. So 30 millimeter in between portion, it will be visible between these two vertical blocks. So this portion of this web, it will be visible as an object line, whereas 15 millimeter from the front side and 15 millimeter from the rear side. So this portion of this vertical web or element number 2 will be observed as a hidden line over here. Similarly, this is another portion of the web which should have been visible from this side, but 30 millimeter at the center. So this portion, it is visible to the observer because it is lying onto the front side, but this portion or even this portion, 15 millimeter on this side and 15 millimeter on this side. So onto the back face of this vertical wall, onto the back face of this vertical wall, so there is a horizontal surface available over here. So this horizontal surface and this horizontal surface, it has been covered by these two vertical blocks over here. So this horizontal surface, 15 millimeter depth, it will be visible as a dotted line from the right hand side projections. This horizontal surface on the back side of this vertical block, it will also be visible as a dotted line projection into the right hand side view projections over here. And another thing we can see, this hole is having height is equal to 25 millimeter. This hole is having height is equal to 15 millimeter. Both of these holes, they will be getting overlapped into the right hand side view projections over here. So now from the top view projections, we have already obtained the diameter of the hole over here. Now we have drawn two horizontal projector lines into the top view projections, and these two projector lines corresponding to the diameter of these two circular holes having diameter is equal to 20 millimeter, they have been appropriately transferred into the right hand side view projections over here using this transfer line. So now because this hole is having height is equal to 25 millimeter, this hole is having height is equal to 15 millimeter, both of these holes, they will be overlapping with each other into the right hand side view projections, and both of them, they are not visible to the observer. So they will be obtained as dotted line or the hidden line projections into the right hand side view projections over here. Now another thing we can check, corresponding to this edge, again we are going to obtain the object line projections at a height of 10 millimeter from the ground over here, so that this face we are able to observe into the right hand side view face as a true shape over here. So the true shape of this face has been obtained. We can check, true shape of this face has been obtained into the right hand side view projections. True shape of this rectangular face has been obtained. The true shape of this vertical face, it has also been obtained into the right hand side view projections over here. So this way we have been able to obtain the front view orthographic projections, the top view orthographic projections, and the right hand side view orthographic projections corresponding to an engineering object for which the 3D isometric projections, they were available with us. I hope that through this discussion you would have understood about the procedure to evaluate the orthographic projections of the solid when the 3D isometric projections of the solid, they are available with us. So this is all for today. So we will be continuing with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.